Hi, welcome back to LeetCode. In this we discuss LeetCode problem 3408 Design Task Manager. So there is a task management system that allows user to manage their tasks is associated with a priority. Okay, the system should efficiently handle adding, modifying, executing and reviewing tasks. So implement the task manager class. So here actually you have first is the constructor task manager. Actually the inputs is vector integer tasks. Initialize the task manager with a list of user task priority triples. So each element in the input list, first is the user ID, then task ID, then the priority, which adds a task to the specified user with the given priority. So the next functionality is the add first function. So it will take three argument. First is the user ID, the task ID and the priority. So it will actually store these tasks as the task ID and the priority, and with the against the user ID. So it is guaranteed task ID is the unique task ID. So next method is edit. So we'll take two things. One is the task ID and the new priority. So for this, against this task ID, we have to modify the priority of the this is a task ID. So it is guaranteed that this ID exists in the system. Okay, and similarly for remove function, we will take the task ID and we will just remove the task ID from the system. And similarly for execute top, it will actually execute the tasks with the highest priority across all the user. If there are multiple tasks with the same highest priority, execute the one with the highest task ID. After executing, the task ID is removed from the system, return the user ID associated with the executed tasks. If no tasks are available, return -1. So we'll actually get three things. One is the user ID, and then task ID and the priority. Correct. So this is the task manager. We have to store this in a efficient way that it will store as a priority as a top. The highest priority will be at the top, or it will be executed first. Correct. And if there are multiple actually tasks are present as the same priority, then we have to store this as the whatever the actual task ID is the greater, that will be stored at the front. Correct, or at the top. So somehow you can actually think about this. This is somehow we have to use priority queue here. Correct, because the highest priority will be executed at the first. So it will be stored at the max heap. Correct. So in the max heap, we have to state two things, because it can be stored as a priority first. It will first. If it is priority same, then we have to decide with the task ID. Correct. Now for other function, like for add, we don't need anything. We will just store this. For edit, we need, as against task ID, we have to modify the priority. So we have to take the any map, or some we have to find out that for any task ID, we have to find out the new priority. So we have to create a new task with the new priority. Correct. So some we have to need a map that actually point the current data. Current data means it will store the what is the user ID and what is the current priority, the old priority, and the task ID. So for against task ID, I will actually modify the new priority, and I will just store the new modified data into the priority queue. Correct. This is actually clear, the thinking, the logic. So this is our data, and for this like for edit and remove, we will get the task against the task ID. We have to do the operation. So we need some mapping kind of that for current task ID. What is actually the current data? Current data means what is the user ID, what is the task ID, and what is the current priority. Now what to do for modify, for edit, we have to create a new data with the new priority, and I will just store this into the priority queue. Priority queue I already explained why actually we need a priority queue. Correct, because whatever the highest priority, that will be executed first. For the next function remove, that will actually what will do, for tax ID, we will first suppose we get this data, that what is the user ID and what is the tax ID and what is the priority. So, and delete this data, that this data is no longer actually valid, correct? And in execute time, execute top function, we'll just we'll see what is the priority queue, in the priority queue what is actually present at the top. I'll check that this is valid or not. If it is valid, like not valid means that actually not present in the map. If it is already removed, so that time our map will say that okay, this data is not present, but it is present in the priority queue. It may be possible, so I will not count. I will not actually handle. I will not actually do any operation. I will just actually discard this and go to the next element. And it may be possible that this data is somehow actually modified. Okay, it may be possible. So I'll check the map, whatever actually from the map. I will check what is actually the updated data. If the current data for this current tax ID, if it is the both are actually equal, that means this is actually updated data. This data is actually updated. We can actually do the operation. If it is not equal, suppose the priority is not different, that means this our current data is backdated. So we have to discard this. Got it? The logic is clear. So what I'll do, suppose for this example 1, I'll just do 100, 110. So this is actually one data, and in the map I will store this for tax ID 101. This is the data. Okay, next is 200 to 20. So the tax ID is 102. Okay, and next is 300, 315. So this is actually 103. Okay, this is the initial data, and from map I will actually pointing this data. In the priority queue, what I will store? I will store this data according to whatever the actual highest priority. And if is the priority key, if the priority is same, then I will resolve this with the highest tax ID. Correct? Now for the next operation, we actually have a add. So add is 404 5. This is the new data, and the tax ID is 104. Okay. Next is edit. What actually edit I am doing? For 102, I am priority key is currently 8. So 102. So 102 is currently pointing this. Correct. So I will create what? A new duplicate data for 102. The user ID will be same, and the tax ID will be same. The priority will be modified to 8. It is clear? It is now 8. Okay, now 102 is pointing to this. Now 102 is not pointing here. Okay. Next is edit execute top. If I do the execute top, then what will be the highest priority here? So in the priority queue, I'll get this 20. Okay, but this is actually correct? No. Why? Because I'll check the 102, that tax ID. What is the current updated data? Current updated data is priority is 8. That is actually different from 20. So I'll just discard this and go to the actually next data. Next priority is 15. So 103 what is pointing? This is pointing this data itself. So what priority is same. So this is the updated data. So I'll just check what is the user ID. User ID is 3. So I'll return here 3. So you can check here. The output is 3 here. Okay. Now this actually already removed. They mentioned that whenever the one task is executed, this will be removed from the queue. Okay. So this is the these 3 data actually currently present in our current scenario. Now next is remove. Remove what actually you are removing? 101 data. 101 means this data have been removed. Okay. So 101 removes means this data is not pointing. I am not saying that this actually removed. So I'll just discard this. I'll just delete this linking. Okay. So there is no actually 101 ultimately. Okay. Now next is this have been removed. Next operation is add. Add what I am adding? 515. So this is a new data. So 105 is pointing here. this data. Now next is execute top again. So execute top, so this 4 data actually is present in the priority queue. So highest priority is 15, correct? So what is the user ID? 5. So I'll return 5 here. It is clear? It is clear how you're getting the correct output. So you can check the length is can be go up to 10 to the 5, and each operation total number of operation is 2 into 10 to the 5. So somehow we have to solve this n log n or log n, correct? N log n or log n, otherwise it will give us a TLE. So just go to the code, then it will be easy. So we actually have 3 data, like we have a data that actually store 3 field. One is the user ID, task ID, and the priority, correct? And for mapping, what I'm storing here for my current map, the task ID against the current task ID, what is actually data? Data means this data, okay? What is the user ID, task ID, and what is the priority? Updated data, it will always point to the updated data. And I have take the priority queue, actually storing this this data, my data, and the vector of this, and the my compare. My compare means we have to sort this. How actually we are sorting this? I will sorting if the priority is less than this, then actually I will actually, it will be whatever the priority is less, that will be actually present at the priority will be whatever the priority is larger, that will be present at the top. So that's why I've just the reverse thing, a priority, you know that Heap is actually what is a different way. So that's why the priority is less, then it will actually store at the bottom. And if suppose the priority is equal, then I will code is miss. If the priority is equal, then I will store this with the error task ID is less than b dot task ID. Got it? Because whatever actually the task ID is greater, that will be present at the top. So that's why if it is smaller than that, will be present at the bottom. Got it? So this we have to pass this compare function to this priority queue. Now what I'll do, for this constructor task manager, I will get the tasks. So for each task I will store this, and I am calling this add function that is already present. I will take 3 things: user ID, task ID, and the priority. Okay, for each task actually I am storing this. So what I'll do, I will create a new data, my data, or actually storing user ID, task ID, priority. And for map, for current map task ID, I am storing the current data, and storing this data into the priority queue, and it will be stored according to this compare function. Got it? And this edit function will, what will do, I'll first check that this data should, this task ID should be present, but we don't need to check because they mentioned that this will be always present. So but still I've checked, and I will check after getting the data, the current data of this particular current task ID. I'll just modify the priority. The priority data of priority will be new priority, and I'll push this into the priority queue again. Okay, so if suppose there is n data present in the priority queue, again I push this new modified data. So now there will be n plus 1 data in the priority queue. Got it? And similarly for remove, what I'm doing, I'm not removing anything from the priority queue. This is, suppose you can say actually lazy propagation. During the execute top, I will check this actually valid or not, this current data. So what I will do, I will just from the map, I will just remove that current task ID. From map I will check, okay, this task ID is present, not equal to n. So I'll just erase this from the map, but still it is present, n elements are present in the our priority queue. Got it? Now for execute top, I will check what, I will just execute one by one. So first we'll get the highest priority. Okay, so I'll get one data, and I will pop this. I will check this current data task ID is not equal to have not been removed, so it will be present in the map. So that's why I will check the current task ID not equal to the mp.end, means this is present in, this is actually valid, not have been removed till yet. And the task ID, the priority, the map, from the map, the modified current data, the priority of the modified current data is equal to the current data from the whatever getting in the priority queue, then it will be the valid data, else it will be backdated. So if it is actually equal, that means this actually updated data. So I'll just I'll just erase this from the map, because they have mentioned that after executing this current whatever the top highest priority data, it will be erased, or it will be removed from the system. So that's why I'll just remove from the map and return the user ID. they mention. Else what will suppose this is actually have been deleted, or the data is actually backdated, then what will I will go to the just pop, I have already popped this, and go to the next hash priority data, and there is no data, that time I have to return -1. They mention that. Got it? Is clear? It's clear, right? If any suggestion, any comment, you can comment on that. If it is actually confusion, if you have any confusion, you can see this video again, and I also share the code link in the description. You can actually also follow that. And if you're not yet subscribed, please subscribe the channel. Thank you.